Yes, okay. So இதெல்லாமே previous year gate questions தான் based on random process. நம்ம random process last class முன்னாடி கிளாஸ்ல பார்த்தோம். ஸோ அதை பேஸ் பண்ணி நம்ம கொஷின்ஸ் இந்த இப்போ ப்ரீவியஸ் இயர் கேட் கொஸ்டின்ஸ் இதெல்லாம் வந்து சால்வ் பண்ணுறோம். ஸோ ஃபர்ஸ்ட் ஆஃப் ஆல் ஜென்ரலாகவே கேட் ஆர் எனி அதர் எக்ஸாம் ஒன்ஸ் அந்த கொஷின் பார்க்கும்போது பார்த்த உடனே இது நம்மளுக்கு தெரியாது அப்படின்ற ஒரு முடிவுக்கு வந்துடக்கூடாது. ஜஸ்ட் உங்களுக்கு பேசிக் தெரிஞ்சதை வச்சு ட்ரை பண்ணணும். ஓகே, இப்போ என்ன கொடுத்துருக்காங்கன்னு பார்ப்போம். They have given some random process x of t, that is 3v of t minus 8. Again, v of t is also a random process. If v of t is random, then x of t is also random. And then they mentioned v of t is having zero mean. Zero mean. That means I know what is the characteristics of v of t. So the expectation value of v of t is 0. V of t is 0. Then they also mentioned autocorrelation function for v. Autocorrelation function for v, that is 4e power minus 5 mod tau. Now they are asking what is the power in x of t. First of all, you should know what is the power formula in the random process. For random signal, power is simply e expectation of x square of t. This is the power of the random signal, power of the random process. So they mentioned x of t is equal to 3 times of v of t minus 8. So again, we have to do the square operation. Okay, whatever the signal given x of t, that we have to do the square. So we'll get 9v square of t minus 48 v of t, then plus 64. Then you apply the expectation operator. Okay, the constant can be taken out, you know that. So expectation of e of v square of t, then minus 48 v of t, and then 64. So now to get the final answer, you should know what is expectation of v square of t, then what is expectation. Again, we have to apply the expectation operator inside. Sorry, here we made a mistake. We have to apply the expectation operator inside. So 9 times e of v square of t, then minus 48 e of v of t, then you know that expectation of constant is always constant. So that is 64. Now what is e of v square of t? So e of v square of t means power in the signal v of t. Okay, but that is not given directly. Okay, so they given autocorrelation function. They given autocorrelation function. So from that you have to calculate the power. From that you have to calculate the power. You know, autocorrelation at origin will give power of that particular signal. The moment I put tau is equal to 0, I'll get 4. So 4 watt is the power in the signal v of t, because autocorrelation at origin will give the power of the signal. So this is 9 into 4. Why I am calculating the power? Because expectation of p square of t, that means power. Then what is expectation of v of t? That means mean value. So they given already mean is 0. So mean of the process v of t is 0. So minus 48 into 0, then only I'll get 64. So 64 plus 36 is 100 watt. 36 plus 0 plus 64. So finally I'll get 100 watt as a answer. 100 watt is the answer. Okay. Next question. The autocorrelation function of the rectangular pulse of duration t. They given some signal x of t. X of t is a rectangular signal. Say, I can imagine like this. It is a rectangular signal with the duration t, capital T in the time domain. Now, what is the autocorrelation function of this rectangular function? So we should know the basic formula. What is ACF, basic formula? Please refer the basic. So expectation of x of t then not expectation. And then directly we can write like this: x of t convolution with x of minus t. Okay, this is the autocorrelation function basic formula. X of t convolution with x of minus t. And another formula is also there, but this is one of the formula. So that means what? For a given signal, you have to find out what is x of minus t. Then again, you have to do the convolution operation. You have to do the convolution operation for this rectangular pulse. First, you should know what is x of t, then x of minus t. Then you do the convolution operation. So finally, you will get the answer. Now, here you should also know what is the convolution. What is the convolution value? So once for a rectangular signal, if you do the convolution, that means both are having equal value. Okay, if both are having equal value means then you'll get the triangular pulse. You'll get the triangular pulse with the duration of 2t. So individually t, then totally it is 2t. So the answer is triangular pulse with the duration of 2t is the answer. Triangular pulse with the duration of 2t. Next, the power spectral density of the real process x of t for a positive frequency is given. Then what is the value of e of x square of t, then e of x of t? அதாவது x of t க்கு Fourier transform pair எழுதணும்னா sx of f இல்லனா sx of omega கிடைக்கும். The power spectral density means in the frequency domain. So instead of in the f domain, they were represented in the frequency domain. They were represented in the frequency domain. So now we want to calculate what is e of x square of t. What is e of x square of t? E of x square of t means power in the signal. E of x square of t means power in the signal. So now the power in the signal I can calculate from the power spectral density. E of x square of t is giving the power. So that power can be calculated from the power spectral density using this formula: integration minus infinity to plus infinite sx of omega d omega. As it is in the omega domain, I have to put 1 by 2 pi. Okay, if it is in frequency domain, here you should not put 2 pi in the denominator. Or if it is in the, as it is here in the omega domain, we are putting 1 by 2 pi. So now 1 by 2 pi integration 9 to 11, then the triangular function. Okay, the triangular function integration. Again, here it consists of triangular pulse, triangular function as well as the impulse, triangular as well as impulse. So for the triangular function, easily I can calculate the area. Easily, either I can apply integration or otherwise using area property, I can easily calculate what is the area, because integration means area. But for impulse, directly I cannot write. I have to apply the integration formula, and also you should note down whether that impulse is within your integral or not. If the impulse is outside of the integral, then definitely integration value is 0, but the impulse is present within your integral. Okay, whether it is within or outside, they will clearly mention. See here, this is the definition of impulse, where omega is equal to 10 power 4, that means 10k. 10k is the answer. Again, you can observe here 10k. So this is indicating 10k, this is 9k, this is 11k, because scale is in the k, 10 power 3. So definitely this impulse is inside this integral. So what I will do, for impulse I will apply the integration. For the impulse I will apply the integration. You know the integration of impulse is always 1. So this is omega minus 10 power 4. That means this is in between 9k and 11k. So definitely this impulse is present inside the integral. This is dw. Then what is the area of the triangular pulse, or otherwise integration also you can apply. I am just applying the area 1 by 2. Okay, 1 by 2 of bh formula. 1 by 2, base is 1, then height is 6. 1 by 2, 1 into 6, and then 1 by 2, 1 into 6. Again, you should note down the frequency is in k. Okay, that means 1k and then 10k. So finally I will put that, okay, in terms of k. Then from this integration of impulse is 1. Okay, integration of impulse is 1. Again, already 400 is there. So 1 by 2 pi 400, 1 by 2 pi 400 plus, okay, 6 plus 6 is 12. 12 by 2 is 6. Already it is in the K scale. So 6K. 6K. So 6000 plus 400 is 6400 is 6400 divided by 2 pi divided by 2 pi. But instead of divided by 2 pi, we are getting pi. Mostly this may be the problem with the negative frequencies also, because whenever spectrum is defined in the positive frequency, it has to be defined in the negative frequency also. So, okay, I will clarify this later. So now we are getting 6400 divided by 2 pi. Instead of divided by 2 pi, they are putting pi. Okay, anyway, I will clarify this doubt in the later class. Okay, okay, I am getting this answer. The next, what they are asking, E of x of t. E means what? Average value. E means average value. E of x of t. E of x of t. Indirectly, E means average. Indirectly, it will indicate the DC component in the signal. Okay, DC component. Indirectly, it will indicate the DC component. Average value means DC component present in the signal. DC component, the effective DC component present in the signal only will become like an average. So here you can observe what is the presence of DC component. DC means generally DC means at zero frequency. At zero frequency, I am not having any value. At zero frequency, I am not having any value. So the average value of the random process is zero. Average value of the random process is 0. So option B is the answer. Option B is the answer. Next, consider a random process where amplitude is √2 sine 2 pi t plus pi, where pi is uniformly distributed between 0 to 2 pi. Then what is the autocorrelation function? Already I have given you the standard formula. Whenever you have a cos omega t plus pi, then what is the autocorrelation function for this ACF? Autocorrelation function for this is a square by 2 cos omega tau. Here instead of a, they given √2. So √2 square by 2 is 1 cos omega. I have already told you tau means always time difference, t1 minus t2, or it may be t2 minus t1. So instead of tau, I have to put t1 minus t2. So finally the answer is cos of 2 pi t1 minus t2. Option D is the answer. For a random variable x is having following probability density function PDF, but the limit is going from -1 to +3, and then totally the range is 4, so definitely 1 by 4 will be in the y-axis. So now we have to calculate mean and variance. Mean and variance. Already standard formula is there. For uniform distribution, mean is b plus a by 2. Variance is b minus a whole square divided by 2. Okay, so what is the final answer? 3 b minus a, 3 plus 1, 4, so 2 is the mean. Then b minus a whole square, that means 4 square divided by 12, 16 divided by 12, 4 by 3. So answer is D. Answer is D. So what is the main observation here? The same distribution, if you put uniformly like this, -2 and then +2, then also you will get the same result, but mean may be different. mean may be 0, but the variance will not vary. Variance actually indicating what is the difference, actual variation from the central value. So variance will not change, but mean may be changing. Okay. Next.
Sir.
Yes. Yes.
Sir, in previous problem answer is B. Mean is 1, sir.
Mean is sorry, B plus sorry, B plus A. Mean is 1. Yes, mean is 1. So அதாவது B plus A தானே கொடுத்திருக்காங்க. B plus A means 3 minus 1 is 2, 2 by 2 is 1. So answer is B only. Correctங்களா? B.
Yes, sir.
Yes. So next, 1 milliwatt video signal having bandwidth of 100 megahertz is transmitted to a receiver through a cable that has a 40 dB loss. Say this is the cable, it is having 40 dB loss. So whenever I transmit the signal, the loss that is present in the entire cable is 40 dB. And then they have also mentioned the effective one-sided power spectral density, that is 10 power minus 20 watt per hertz. Then what is the signal to noise ratio at the receiver? Here we have to calculate what is the signal to noise ratio. So they have clearly mentioned what is the power available with us, that is 1 milliwatt. And also they given what is the bandwidth of the signal. The bandwidth is 100 megahertz. If the power is 1 milliwatt, we have to write in terms of dB, because power means if you operate in terms of dB, then it will be simpler in general. And also answer is given in terms of dB. So I will convert this input power into in terms of dB. Then the power available with us is minus 30 dB. Okay, just apply the 10 log formula, minus 30 dB. Then already loss is there. So what is the power, signal power I will be receiving at the output? The signal power is equal to input power minus loss. Input power is minus 30 dB, and then minus loss is there already, that is minus 40 dB. So totally the power available at the output of the cable is minus 70 dB. Now I have to concentrate on the noise power. I am indicating N, means N is the noise power. So noise power, you know that noise power is N0 into B. N0 they are given 10 power minus 20. Then bandwidth also they are given 100 megahertz. That means 10 power 8. So I will get 10 power minus 12. Then noise I will represent in terms of dB. Then I will get minus 120 dB. Now I know what is the signal power. I know what is the noise power. So we want to find out what is signal to noise ratio, or otherwise in terms of dB, signal power minus noise power. In ordinary number, we have to take the ratio. In terms of dB, we have to find out the difference. So what is the signal power? Minus 70. What is the noise power? Minus 120. Already minus is there. So 50 dB is the answer. So in this problem, noise with uniform power spectral density of N0 is passed through a filter having HW transfer function in frequency domain, that is 2 times exponential of minus j omega TD, followed by an ideal low pass filter of bandwidth B hertz. Then what will be the output noise power? See what they are telling. There is some noise with power spectral density N0. Okay, again the noise is having uniform power spectral density. Okay, noise is having uniform power spectral density, is passed through some system. That system is having response, magnitude response in the frequency domain, that is h of omega is equal to 2 times of e power minus j omega TD. Then after that, it is passed through low pass filter, ideal low pass filter. Ideal low pass filter means it will allow all the frequencies below the cutoff range, corresponding cutoff range. Okay. So now, first of all, this noise is passed through this system. Okay, whether this may be the noise or signal, but it is passed through some system. Okay, yesterday I have given you one formula. Say this is the power spectral density of the noise at the input side, power spectral density of the noise at the input side, say S1 of F. Whether this may be the noise or signal, yesterday I given you one formula. What will be the noise power at the output of the system? So output noise power is equal to, please refer the formula, output noise power is equal to, what is the magnitude of the system, just to take the square, because system will be defined in terms of voltage. So we have to find out the, instead of voltage, we have to find out the power response. So just to take the square, then multiply the input noise power. Multiply the input noise power. So simply what will happen, this N0 will be multiplied by 4. So here I will get 4 N0. Again, this frequency is extending from minus infinity to plus infinite, or from 0 to infinite. Now what they are telling, so now N0 has become like 4 N0. Now also the bandwidth is infinite, but after that it is passed through low pass filter. Say the low pass filter is having bandwidth B. Again, low pass filter magnitude will be 1, because it is a ideal low pass filter. Ideal low pass filter will have magnitude of 1, then bandwidth they mentioned like B. Then this signal is passed through that filter. So definitely there will not be any magnitude change, but there will be the bandwidth restriction. Okay, because this filter will allow the frequency only up to B. So finally what I will get at the output of the low pass filter, after the low pass filter, I will be getting 4 times of N0, but up to the bandwidth of B, up to the bandwidth of B. So this is the output of the low pass filter. So what they are asking, at the output of the low pass filter, how much noise power will be there? So I know what is the shape at the output of the low pass filter. This is the spectrum shape. Then you just take the area, that is the power. So 4 N0B is the answer. This is the last problem. Then I may not be last. Okay. 7th problem. An output of communication channel is a random variable V with the probability density function as shown in the figure. What is the mean square value? See, in general, you know the mean square value for standard function, say such as uniform distribution or otherwise normal distribution. Okay, for a standard function, already standard formulas are there. But here, this is the new function. Okay, so you should know the regular formula for mean square value. So what is the mean square value? E of x square. What is the mean square value formula? E of x square. E of x square means integration of x square f of x dx is the mean square value formula. So here instead of variable x, they given like v. So that means E of v square, then integration of v square. Then this is instead of f of x, they given f of v, then dv. Again, what is the range? So you have to go from 0 to 4. In general, the integral goes from minus infinity to plus infinity, but here the signal is defined from 0 to 4. So this is from 0 to 4. 0 to 4. Again, v square is there. Then what is f of v? Okay, f of v. What is the nature of f of v? So you have to write the equation for this one. You have to write the equation for this one. I think this has to be k. Say, I think this point is k. Then what is the equation of this one? Equation of this one, I hope y equal to mx plus c formula, where c is 0. So slope is k by 4. So k by 4 v is the equation of this line, that is k by 4 v dv. Now you take the k by 4 outside, then 0 to 4 v cube dv, k by 4. Again, I think we have to calculate k. Okay, I'll tell you how to calculate k. You know that whenever the probability is given, the integration of p of v from 0 to infinite or from minus infinite to plus infinite has to be 1. So as per that concept, what is the integration of p of v? That is k by 4 v dv is equal to 1. Again, this goes from 0 to 4, is 0 to 4. Or otherwise, a simple method also I can tell. Instead of going, you can do integration also, or otherwise just to try to calculate the area here. The area under this function has to be 1, because it is the probability density function. Any probability density function, area, overall area has to be 1. So what is the area here? 1 by 2, 4 times of k has to be 1. So k is equal to 1 by 2. K is equal to 1 by 2. Okay, we'll come here. So integration of v cube dv, then once if we do the integration for this one, you'll be getting v power 4 divided by 4. This is 4 and then 0. What is k? K is 1 by 2. Then 1 by 8, 4 power 4 divided by 4. That was the answer was done for. Are we getting any answer here? So 8 is coming. So 8 is the answer. Visible or the problem? Has anyone visible? Is it visible? Anyone? Cornerல வச்சிருக்க visible இருக்கா உங்களுடைய ஸ்கிரீன்ல?
Yes, sir.
Okay. Which of the following function can be a valid power spectral density of a real wide sense stationary process? Okay, so you should know the properties of power spectral density. Properties of the power spectral density. Okay, yesterday I told you the power spectral density is always even function. The power spectral density is always even function. That is the one property. And then power spectral density value can never be negative, because power cannot be negative at any point of time. So these are all the two properties. Okay, so here, anyway, at any point of time, we are getting positive values only, because there is no negative sign. Definitely all the functions are satisfying that second property. Okay, power is always negative. But whether all this function is satisfying this property, even function property, that you have to verify. First of all, we'll concentrate on the function c. What is the nature of this function? They are telling 25. 25 means constant 25. Then del of f minus 16. That means at exactly 16, we will have a impulse. So definitely this is not the even function. Even function means it must be symmetric with respect to y-axis. Even function means it must be symmetric with respect to y-axis. So it is not a even function. It is not a even function. Similarly, you try to apply instead of f, you try to apply minus f. Definitely this is also not a even function. This is also not a even function. So only this one will satisfy the even function property. So they are having constant value of 10, and also they are having one impulse at y-axis, exactly at y-axis. So this diagram will satisfy the concept of even function. So option D only satisfying that power spectral density property. So D is the answer. Next, consider the following statement regarding the autocorrelation function Rx of tau and choose the correct option. Just we should know the autocorrelation function properties. First one, Rx of tau, autocorrelation function is even function of tau. Yes, it is correct. Then they are telling autocorrelation origin is less than at any other point. Tau can be anything here, but this is not true. Okay, I already told you autocorrelation at origin is the maximum. Okay, at tau is equal to 0, you calculate something, that is the maximum value. At all other point, it has to be minimum. So it has to be in the reverse format. So this is wrong. Then third one, Rx of 0 instead of tau, if you put 0, that will give power of the signal if it is a power signal, or energy of the signal if it is energy signal. Here we have to make note. So in the last class, I told you Rx of 0 will always give power, but it will give energy also, because we do not know what is the nature of the signal. Whenever the signal is deterministic or random, maybe the x of t may be power signal, or it may be the energy signal. It may be the energy signal. So if it is a power signal, directly you will get the power. If it is an energy signal, directly you will get the energy. That is the another idea here. So far we are discussing only about the power, but if at all if the signal is energy signal, given signal x of t is the energy signal, then Rx of 0 will give directly the energy present in the signal. So option 1 and 3 is correct. Option 2 is incorrect. So here statement C is correct. So around ஒரு 10 ப்ராப்ளம்ஸ் வந்து நம்ம டிஸ்கஸ் பண்ணதுலேருந்து பார்த்துருக்கோம். ஆல்ரெடி நம்ம கவர் பண்ண டாபிக்ஸில் இருக்கிற ஃபார்முலாஸ் பேஸ் பண்ணது. ஒரு சிலது லைட்டாக அதுலேருந்து டீவியேஷன் ஆகி கூட இருந்திருக்கலாம். ஸோ அதெல்லாம்